Well, good afternoon, everybody. This is Dave Jones with Storm Center Communications and GeoCollaborate. It's Thursday, November 7th, 2024, a little bit before 2:30. It's about 2:24 here on the East Coast. This is a tropical update for the All Hazards Consortium, Sensitive Information Sharing Environment, where we share information between State Emergency Operations Center private sector liaisons and their private sector partners to keep everybody on the same page. Make sure we can transport goods and services across state boundaries and get electricity restored when disasters occur. So this is the tropical update, and we do have Hurricane Rafael. It is west of Key West right now. You can see the enhanced sea surface temperature colors here to show you that Rafael is not in ideal sea surface temperature conditions, but it is in enough sea surface temperature height, in other words, around 80 degrees, where it can still feed on that warmer water of the Gulf of Mexico. But it is playing with some upwelling with temperatures in the mid to high 70s upwelling that may cool its surroundings. However, the satellite picture, you can see this is the eye of the storm right here. It has been getting some enhanced convection to it. Let me show you this full screen and show you what it looks like. So here's the rest of the Gulf of Mexico. You can see it's looks relatively warm, not as warm as the Caribbean here. And I can move that down. These are all temperatures in the mid to high 80s. But you can see as Rafael moved across Cuba last night into early this morning, it did cool some of the waters a little bit. Now it's taken on a sort of a westerly track. And it's in semi-cooler temperatures. Let me take you a little bit closer here to the mesoscale sector. We like that one. That's the one that shows us imagery every minute. And look at this. You can see those thunderstorms. They're the bubbles that come up the top of the clouds. These are cirrus clouds. The really thin ones, these are high up, maybe like 30, 40,000 feet in the air. These are high up in the atmosphere. But these thunderstorms can bubble up through those cirrus clouds. They're called overshooting tops. And they are the most severe convection or thunderstorms that we see around the center of the storm. Now, what's been interesting over the last several, I'd say couple of hours, is this area of thunderstorms has increased, and it looks like it is rotating around the eye here. It tells me that the storm might be a little bit stronger than it was during the 10 o'clock AM advisory from the National Hurricane Center. I'll show you those stats. Those stats were 24.5 north, 85.2 west. These are 10 a.m. Eastern time. So that's about 4.5 hours ago. Next update's going to come from the Hurricane Center at 4 o'clock Eastern time. Max winds 100 miles per hour, movement west-northwest at 9 miles per hour, and the central pressure at 971 millibars. Now, the Hurricane Hunter aircraft from NOAA just completed their mission. They landed back at Lakeland Air Force, or not Air Force Base, but Lakeland Airport in basically central Florida. And they did find winds up around 105, 106, 107 miles per hour at flight level. So they may maintain it at 100 miles per hour or maybe increase it to about 105 miles per hour at 4 o'clock. We'll see what happens there. Not really a big deal since this storm is out in the Gulf of Mexico now and not threatening any U.S. interest right now. But these thunderstorms have been growing around the center. The latest recon reports have said to the south and the southwest, the eye was open somewhat to the south and southwest, and that might be that area. We've seen some drier air come in and get sucked into the hurricane a little bit, and I have some neat satellite imagery I do want to show you that shows you that dry air and how we can use satellites to really, it's almost like conduct an MRI of the hurricane so we can see at what levels dry air is moving in, how it might really decrease some of the winds or the intensity of the storm, and then where moisture is and where that might be causing flooding even in the southeast part of the U.S., even though the hurricane is out over the Gulf of Mexico. It's really fascinating how weather works. And so as far as watches, warnings, and advisories, nothing No tropical storm warnings, no hurricane watches, no tropical storm watches or hurricane warnings in effect in the United States anywhere. So that's a pretty easy update for those statistics. But what I want to do is I'm going to scroll over here a little bit because here's South Florida. This is South Florida, and you can see we still have high clouds, cirrus clouds, influencing South Florida, and even some thunderstorms that moved across. This is Cape Coral in here, and Fort Myers and Fort Myers Beach right here. I'm going to show you real quickly. Let me see if I can switch over to the radar data here. There we go. So this is radar data that's live here at 2:30 p.m. And you can see way on the edge of the radar. This is out of Key West. You can see the eye, but the radar beam is pretty high up in the atmosphere. Look, this is part of the eye wall. Strong thunderstorms there. But look over here in Cape Coral and Fort Myers Beach. They may have had a thunderstorm and some nasty weather just passed through there, even though the storm is 200 miles or more west of Key West, Florida right now. But we still are tracking individual cells. These are offshore, but these may be where water spouts are and some very heavy downpours. Indeed, we are seeing more of that storm, even down across Cuba. Look, some individual thunderstorms here on the outer bands, still causing localized flooding there as the hurricane is still far away now from Cuba. And here's the dry Tortugas. Here's Key West in here. And you can see these storms even passing through some of the keys. So still influencing the part of the United States. As we take a look now back at the high resolution 1-minute satellite imagery, look, even up towards Tampa. This is St. Pete Beach and Paso Grill, up towards Clearwater. There are clouds that are streaming out of Hurricane Rafael. Look at this. These are the cirrus clouds going clockwise because it's high pressure evacuating that air over top of the hurricane. There's a high pressure, and that's making these clouds move clockwise. And you can see the high, thin clouds moving over. So if you're on the Space Coast right now in Florida and you see these high, thin clouds moving east, that is the outflow from Hurricane Rafael. It's pretty amazing. And I'll back out here just a little bit so you can see what's going on. And I can even go to the wider sector here so you can see what's happening. Look at this. So here's the hurricane, and here's the outflow coming out over Central Florida, right over the Space Coast, where, look at this, water temperatures are pretty cool. Why? We've been talking about this for about 5 weeks. Strong east to northeasterly winds have been hitting the eastern Florida coastline, creating a lot of upwelling and a lot of cold water and a lot of beach erosion. And there still are small craft advisories and coastal flood advisories because of strong high pressure that has been anchored over the East Coast. Remember, clockwise winds, bringing those winds in from the east. And that has been pretty amazing. But let's dive back down into the hurricane here for a second, because I want to show you something really fascinating. So I'm going to go over to GeoCollaborate here for a minute because I want to show you those buoys. Remember those wave spectral drifters that can measure the wave heights that were dropped during Hurricane Helene and Hurricane Milton? Well, some of those wave drifters have drifted into the Gulf of Mexico and have drifted into the path of Hurricane Rafael. The Scripps Oceanographic Marine Lab, they have turned on the wave reporting from these drifters. And now we can see what the wave heights are. And those drifters in relationship to the eye are right in this area. And I'm going to go over to GeoCollaborate and I'm going to show you what it looks like from the standpoint of those wave drifters. So here we are. I have the latest sandwich product from GOES turned on. I'm going to zoom in here just for a minute. And look at that. The satellite image just updated here. So here is the eye of the storm This is the eye of the storm. Here's those strong thunderstorms that we just pointed out in the GOES data. This imagery is also from GOES, but it's enhanced so we can see that overshooting top. Okay, so here's the eye of the storm. It's getting a little bit covered here with cirrus clouds, but look at these wave drifters, and we can click on them now. So this is what I want to show you. Look at this wave height, 19.9 feet, significant wave height, 20-foot waves out here by the center of the hurricane. 20-foot waves. These drifters are meant for NOAA ocean research, so we can put this data into models and also validate and verify wave measurements from the microwave sensors that are on board the NOAA P3 aircraft. They are taking the measurements of the wave height and LiDAR measurements to make sure that we can identify wave heights from the aircraft. And these buoys help us to validate those measurements. So 19.9 feet here. Let's see what they are just down to the south. Look at that, 14 feet to be expected, a little bit further away. And there were really large wave heights. Look at this. From this drifter here, 34-foot wave when the hurricane was moving through here. That is 10.3 meter waves. 34-foot waves. Can you imagine that? And look at this big thunderstorm. This is blowing up here off of the bands of Hurricane Rafael. This one up here, what is this one looking like? This one, 13-foot waves. 13-foot waves. So we had 34-foot waves when the hurricane was moving through here, and this satellite imagery is updating in basically near real time. This one to the north doesn't have it turned on for the wave heights. See the water temperature though, 81 degrees. And even around the hurricane where it's churned up some water, a little bit cooler. Look at that, a little bit cooler. 79-degree water temperature. So that's right on the borderline of being able to maintain energy for a hurricane. Let's see what this water temperature is here down to the south, 81.4. So not as low as these water temperatures. So let's go up here to the north just a little bit and see what these wave heights are to the north of the storm. 16 feet. 16-foot waves. Boy, you do not want to be anywhere near this storm as it's pushing out its strong winds and creating these monstrous waves. 16-foot waves here, and then there's some drifter buoys here a little bit further to the north. Look at this one here. Let's see what that one is. 12-foot waves. 3.67 meters. Water temperature 79.5. So a lot of these water temperatures are getting cool enough now where they could be impacting some of the energy that the hurricane needs to continue to maintain its strength. Now, here's some of those clouds I was showing you coming across Florida. There's some scattered storms east of Port Charlotte in central Florida here. And there's also a little bit of a surge still, 1 to 2 feet here in Key West, 1 to 2 feet of peak storm surge because the winds are still pretty strong from the south. And I can show you that as well, just show you some of the flow around this storm and how it's showing up here. So envision the hurricane with the counterclockwise winds and then still around here coming up over Cuba and coming into Key West here where there's still a chance of a 1 to 2 foot surge. I know some of the waves were crashing on the seawall there by the southernmost point where that buoy is. Big tourist attraction. I'm sure many of you have visited that location before. But let me show you what it looks like from a wind standpoint. Here is the center of the storm and here's the wind flow. Now let me move this up just a little bit more. So here's the center of the storm. This is where the 100 mile to 105 mile per hour winds are right here. And you can see the winds and the direction they're taking. So in Key West, look at that. Southeast wind still gusting 20 gusts to perhaps 30 miles per hour and pushing some water there. And look, there is even a little area of stronger winds close to the land there, close to Key West. And then even if we go a little bit further to the north, let me zoom out just a little bit here, you can see that circulation of the hurricane. These are sort of, I'd call them the dangerous wind field right here, tropical storm force winds. And closer to the center are the hurricane force winds, where it can be quite nasty. And boy, those, I can't believe, those 34 foot waves that we saw back over here on GeoCollaborate. 34 foot waves from this one. Yep, 10.38 meter. That's just incredible at a dominant wave period of 13 seconds. So every 13 seconds, there was a 34 foot wave coming by this drifter. Man, if you were in any sort of boat, I think you'd be seasick just about immediately going up and down. So 34 feet. That's pretty incredible. Now, what I would like to show you as well from this area is I'm going to go back and show you some satellite imagery, and I'm going to add here while I'm talking, brought in the GOES data, and I've also turned on the total precipitable water. Now you can see the GOES imagery kind of looping underneath, but what I want to point out here is all of this moisture. This is very moist air right here being brought into the hurricane, and some dry air that's being ejected in as well. But what I want to point out here is this very moist air is also streaming off of the storm. See this? This is all very moist air here, and it's being pulled up through Florida into Georgia and into South Carolina, where a frontal system and dry air behind it, a frontal system is squeezing it out. And this is what it looks like on GeoCollaborate. So I've zoomed into Georgia and South Carolina here, and you can see the rain, the heavy rain close to Savannah. Look at this red area here. This is a flash flood warning going on right now. So all of that moisture that you can't see in the radar data because it's moisture, but we can see it in the GOES data. Look at it. See, it's being streamed up here over Georgia and over South Carolina, and then it's being squeezed out as heavy rain here in the radar data. And these are all flash flood watches, flash flood warnings. This is a flood warning, a large, broad area of flooding going on in Georgia, near Hinesville, Savannah, Vidalia, just east of Vidalia and south of Statesboro. Major flooding going on there right now, all because of the moisture being pumped out of Hurricane Rafael and the tropics, and a frontal system that is basically stationary. You can see kind of part of it in the rain, stationary right over here, and it's really causing these heavy rain showers that are lasting for, we'll call them intense downpours. That's really what they are. So I want to cover just a little bit related to the hurricane because it is, you can see just a little bit of the eye of the storm right in here. Look at that. This is from that Tampa Bay radar or the Key West radar that I showed you earlier. Here are those buoys in the ocean, and we can see the wave heights. Well, this particular one is turned off, but we can see wave heights even before the storm here. Look at this, 7-foot waves well before the storm, and 7.3 foot waves. So these two drifters are in sync, and they are really indicating what's going on. Now, let's focus again back on the hurricane, and I want to turn on the products related to the hurricane. I'll turn off the Weather Service radar data, and I will turn on the track forecast and the latest cone forecast from the National Hurricane Center. Now, this is really interesting because the hurricane is moving basically west. The forecast in 12 hours by 6 o'clock this evening is for it to maintain 100 mile per hour winds, then to go down to about 90 mile per hour winds This is a Category 1 hurricane. It's Category 2 right now with 100-mile-per-hour winds. Then down to 85-mile-per-hour winds, and then decreasing to 75, and then becoming a tropical storm and heading to the south. Now, this is the official forecast from the National Hurricane Center, so that's the one that we're going to go with. But it's very interesting. There's a lot of diverging models. Some take it to the south. Others, like the operational model, take it to the north, dissipate it, and then bring the moisture up over southeastern Louisiana. So if that is the case, then we'll be talking about rain, hopefully not flooding rains, but rain from a tropical system that could cause localized flooding in parts of southeast Louisiana. So we're going to keep you very in tune with that and where this storm goes, because once it reaches about this location, it has a decision to make, and it has some competing things that are going on. For example, I'm going to turn on the SPC product for 3-day rainfall. This is the excessive 3-day rainfall chance for the southern part of the United States. There is a pretty large low-pressure system that's been giving Colorado and northern Arizona lots of snow, a lot of snow, some places 4 feet of snow. And that's going to move out into the Midwest and cause this frontal system and trough. It's going to come in to the Midwest. So that's why there is a chance of heavy rain in Oklahoma and Texas, and then another area here in Arkansas down to Louisiana. If this trough digs deep enough, it may pull the hurricane to the north. But if it doesn't dig deep enough, the storm may fall into the influence of higher pressure that's inching in and drive it to the south. So we're going to have to watch it by this time here on the 9th. So today's Thursday. So on Saturday at 6 o'clock, we're going to see which direction the storm's going to go, south or it's going to curve to the north. So I wouldn't totally lift my guard along the Gulf Coast, but you can breathe easier because the official forecast of the Hurricane Center has Rafael turning to the south, no longer a threat to the United States. As a matter of fact, they've canceled all the future hurricane recon missions because it doesn't maintain any threat to the United States or our partners in Mexico, and they expect it to just sort of meander around here and dissipate. So they don't want to waste resources on flying these planes out there if the official forecast has it remaining down here. But these areas of intense rainfall and potential flooding do need to be paid attention to throughout Oklahoma, Texas, and Arkansas, Tennessee, down into Louisiana and Mississippi. And this is ongoing right now, this flooding in Georgia and South Carolina. So that's the tropical update for today. And I just wanted to bring all this to your attention. I think it was just really spectacular to see those ocean observations from those wave drifters. We are watching Rafael. It looks to me like it might be intensifying. This convection is increasing in intensity a little bit, and I can enhance that imagery as well with infrared. And you can see what's going on as it loads in some of these infrared images to combine. So you can see that area of red that's increasing. And if it wraps around the eye, we're still going to have an intense hurricane, maybe maintaining Category 2 status over the next several hours or so. But we'll see what that 4 o'clock advisory does. Anyway, thanks for playing along with me here with this update as we geeked out a little bit with those buoys and some different data. We will keep you posted. I'm Dave Jones with Storm Center Communications and GeoCollaborate. This has been an update for the All Hazards Consortium Sensitive Information Sharing Environment. Stay posted. It is November 7th. We have an intense hurricane in the Gulf of Mexico, so we never want to drop our attention whenever that is going on. And so we'll be back with another update either later this evening or during the early afternoon tomorrow. Thanks so much for watching. Please watch out for yourself, and please take care of your neighbors.